Hello everyone, welcome back to General Maths Unit 1 to Chapter 8C. And today we're going to learn the Planar graph and the Euler's formula. The first thing we're able to classify the graph about what's the planar graph looks like. And we're going to redraw it and to become the planar form. And also the second half we'll be doing the Euler's formula and this Euler's formula to find unknown properties of the planar graph. So planar graph is actually pretty easy to understand. So planar graph can be drawn on a plane, so page surface. So like drawing any surface, and there's no edge intersect or cross except at the vertex. So what does that mean? A planar graph is no intersecting the edges. So so we can say if we had a graph A, B, C, D, so it's like that, and that's the planar graph. But if we had 4 points, but the crossing, see that? The crossing, and that means non-graph for the planar graph. Okay, hopefully that makes sense. And so let's do a quick example. So we're gonna redraw this kind of opposite the planar form. So the first thing first we could do is we have A to connect B, A to connect D, but no B. So we have to drop A to connect with D. And A connect to the C, but it's a crossing, but we can connect the D. So we can say A connect to C. So that's a C. But here is the B, so which is B have to connect with D. So how we do this? So we can replace the edge D to B to curve a line to avoid the intersecting another straight edges. So which is we can do, so we can do that way. So we can connect D. So and because B and C are connecting as well, so that's the final part. So that means we are avoid about the intersection line. So hopefully that makes sense. Now you can try this kind of question. Hopefully that can help you to analyzing. I can change A and D, or I can change B and E. So it's totally up to you. So just make sure that's become the planar form. And also remember, you have to be connected to the same line. So which is A to B, A to E, A to D, or C to D. You have to connect as together. So next one, let's try to talk about the face of the graph. So what's a face? So if you have the graph, the opposite can be regarded and dividing the papers and drawing on into the two regions. So the regions is called the face, which it means the face can be the space may enclose the within the connected edges, and the graph can be showing surrounding the graph. So on the right hand side, we can say the face face 1, face 2. So face 1, which is like your graph, and then the phase 2, which is the regions as well. And for this one, we can see we have 4 phases. So phase 1, phase 2, phase C, and phase 4. So which is divide the paper into the 4 regions, which is using the edges to define. And the Euler formula means, so make sure this one put into the bound reference. So number of vertex plus number of faces equal to the number of edges plus 2. So I make sure you guys know this ruler formula means the number of vertices, so the points, and plus the number of faces, so faces, and equal to number of edges plus 2. Okay, so hopefully that makes sense. And V representing vertex, F representing face, E representing edges, and 2 is plus 2. Okay, so let's try the examples, okay? So we're gonna write down the numbers, vertex, and number of edges, number of the faces. So let's have a look. Imagine this is our the planar graph. So there's no crossing together, which is fantastic. And then what we do is we're gonna find a vertex. So vertex are equal to A, B, C, and D. So we have 4. So 4 vertex. And now we do edges. What am I trying to do? So edges. So edges are equal to how many edges we have. So we can say A to B, and A to D, and A to C, and also B to C, and B to C again, and B to D. So 1, 2, 3, 4, 5, 6. So we have a 6 as our edges. Now we're gonna figure out the face. So the face are equal to, we can say face 1, face 2, face C, and remember we have together as face 4. Okay, so we have 4 faces. So we verifying the ruler formula, so which is we can try to rewrite. Question B is ruler formula will be equal to V plus F equal to E plus 2. So which means 4 plus 4 equal to 6 plus 2. 8 equals 8, which means verified. Yeah. So, and another examples I want to show you guys. So first thing first, we need to make sure to consider to rewrite become the what I call the planar graph. But we can see clearly we are crossing. So I'm gonna change this graph to A E. So we say A E. So we connect, which is fantastic. Okay, sorry, that's not straight line at all. Okay, and A to C, so connected, perfect. And C to B are connected, and D, so E to D are connected, and D to C connected, perfect. But we had E to B, so we're gonna do a quick curve connecting. So now we have a pretty nice graph and for our planar graph. Okay, so that's pretty nice. And we're gonna find vertex. So vertex equal to 5 and edges equal to how many edges we have. Let's try 1, 2, 3, 4, 5, 6, and 7. And also we have face. So face equal to face 1, and also we have face 2, face 3, and we have a face 4. So we have 4 faces. So, and we're gonna verify the ruler formula. So we do 5 plus 4 equal to 7 plus 2, which is 9 equal to 9. Verify. So that's the question you're probably gonna see in the SAC or final exams. So hopefully you guys are able to do this kind of question. And I will see you guys next time. And example 3, I want you guys to have a look, by the way. Sorry, I forgot to say. You're gonna see some really question like that, but we're gonna do this one during the class time. Yep, alright, I will see you guys next time.